In this video about the basics of Hurst cycles, we're going to be discovering two further principles defined by Hurst which explain the way in which multiple cycles influence the price movements of financial markets. Those principles are the principle of harmonicity and the principle of synchronicity. We are discussing both principles in this video because the two principles work hand in hand in the way in which they influence price movements. The principle of harmonicity states that the wavelengths of neighboring waves in the collection of cycles contributing to price movement are related by a small integer value. That sounds more complicated than it is. We met the collection of cycles in our previous video about the principle of nominality, in which I presented the nominal model. And a neighboring wave is simply a cycle which is 1 degree longer or 1 degree shorter in that nominal model. And so, in fact, the principle of harmonicity we met in the previous video, because part of the principle of nominality was that the wavelengths are harmonically related. So this principle means very simply that each cycle in the nominal model has a wavelength that is either 2 or 3 times longer than the cycle that is shorter than it. That gives us a 2-to-1 or a 3-to-1 ratio. Now, Hurst mentioned the numbers 2 and 3. He didn't mention any other small integer values, but it is possible that other integer values come into play. Let's take a look at the part of the nominal model that was defined by Hurst. You will see that the ratio between the wavelengths of these cycles is in each case 2-to-1, except for one case in which the ratio is 3-to-1. And that is highlighted in yellow there. It is the ratio between the 18-month cycle and the 54-month cycle. If we step back a little bit and take a look at the part of the nominal model that has been developed since Hurst's initial work, you will see two cycles highlighted in yellow, the 5-hour cycle and the 1-hour cycle. That is because those cycles have different ratios with the cycles longer than them. The 5-hour cycle, for instance, has a 5-to-1 ratio with the 1-day cycle, and the 1-hour cycle has a 3-to-1 ratio with the 160-minute cycle. Now let's move on to the principle of synchronicity. This principle tells us that waves in price movement are phased so as to cause simultaneous troughs wherever possible. Phasing means very simply where we are in the progress of each cycle, moving from a trough to the peak. So it is where that cycle is positioned relative to time. And so this principle means that the troughs of cycles occur at the same time or synchronously, and therefore, very importantly, the peaks are not synchronous. Let's take a look at some theoretical examples of cycles. As I've mentioned in a previous video, a cycle can be represented by a simple sine wave. This is an example of a single cycle, 2 waves of that cycle. Now let's add another cycle into the mix. Here is that same green cycle, but we have also added a purple cycle. These cycles obey the principles of harmonicity and synchronicity, because the wavelength of the purple cycle has a ratio of 2-to-1 to the wavelength of the green cycle. And they obey the principle of synchronicity because their troughs are synchronized where possible. Notice that where possible, because of the fact that the green cycle has a trough that cannot possibly be synchronized with the trough of the purple cycle, because of the fact that the wavelength of the purple cycle is twice as long as the wavelength of the green cycle. An important observation to make is that because the troughs are synchronized where possible, the peaks are of course not synchronized. The green cycle peak is never synchronized with the purple cycle peak. You will notice in this diagram that there is also a blue line which represents the combination of these two cycles. We're going to be coming back to that idea in a future video. Let's add another cycle to the mix. Here we have added an orange colored cycle, which again obeys the principle of harmonicity, The wavelength of the orange colored cycle is twice the length of the wavelength of the purple cycle, and this cycle also obeys the principle of synchronicity. The troughs of the orange cycle are synchronized with the troughs of the purple and the green cycle where possible. And of course, that also means that the peaks of these cycles are not synchronized. You will not find a synchronized peak between the green, the purple, or the orange cycles in this diagram. Again, we have combined the results of those cycles into a blue line, which is demonstrated in this diagram. You will notice something else about this diagram, which is that the orange cycle has twice the amplitude of the purple cycle. That is something we're going to be coming to in our next video, when we are going to start speaking about the way in which we combine these cycles, and we will introduce the principle of summation.